there is a wheel, the diameter is given to you, okay, and it is rotating about point O. Now, if the wheel is rotating anti-clockwise direction, then calculate the clockwise moment. So the clockwise moment will be responsible for this one, because this weight that is acting over here is going to cause an anti-clockwise moment. Okay, so answering the first question, the clockwise moment. So this is the force and this is the axis. So therefore this will be the perpendicular distance. So torque is equal to F into perpendicular distance, that is 100. Now what is OB? The diameter is 40, therefore OB will be 20. So that will be 2000 gram force centimeter clockwise. Okay, so that is the first answer. Now how much will be the anti-clockwise torque? So this is the force that is responsible for that. So therefore, this is the axis, and we know that it has to be force into the perpendicular distance. So that is the reason why this is not the perpendicular distance. The perpendicular distance is this. Okay, therefore, it has to be x multiplied by PO. That's the distance from this axis till the point of application of force or line of action of force. Okay, now because it says that the torque is anti-clockwise, so this particular torque that we are talking about has to be greater than 2000, because the clockwise is 2000, and if the wheel has to turn anti-clockwise, the anti-clockwise torque has to exceed 2000. Therefore, I will say that x multiplied by PO has to be greater than 2000. Okay, now one thing we know, that this particular distance is equal to 20. So therefore PO has to be less than 20. But even if you consider this to be 20, okay, so let PO be equal to 20, then what will be x into 20 has to be greater than 2000. So x has to be greater than 2000 divided by 20, that is 100. So x has to be greater than 100. Okay, so if we are considering PO to be 20, still x has to be greater than 100. Then obviously when PO is less than 20, x has to be further greater. So the answer to this question is x has to be greater than 100 gram force. Okay, then only this wheel is going to have an anti-clockwise direction. Okay, so I hope you have understood the question. Let's move to the next one. A uniform meter scale is in equilibrium. Okay, again, this is 0, this is 100, so this is 50. The weight of the scale will act at its center. Now this is in equilibrium, therefore the clockwise and the anti-clockwise moment have to be equal. So how much is the clockwise moment? W times the distance. So this distance from 30 centimeter to 50 centimeter is 20. And this, which is anti-clockwise, is again the force multiplied by this distance. So that will be 40 into 25. Okay, because from 5 to 30 it's 20. 20 goes 2 times, so weight has to be 50 gram force. So the weight of the scale is equal to 50 gram force. So we get the first answer. The second question is, how can the meter scale be brought in equilibrium if the knife edge is moved toward the center? So the question that they are asking, the weight of the scale, which is acting at 50, okay, we have got this as 50 gram force. Now if this knife edge is moved over here, now you can see that instead of 30, it will be somewhere here. That means this distance will increase. That means the 40 will now no longer will be multiplied by 25. It will be multiplied with a bigger number. Then this will not be equal, okay, because it will be greater. The anti-clockwise will be greater. So for it continue to be in equilibrium, okay, I will have to move this 40 also closer, so that this distance, okay, should be such that the product of 40 into this distance will be equal to the product of 50 into that distance. Okay, so how can you bring the meter scale in equilibrium? You can also move 40 gram force toward the center. That's the answer. Okay, move 40 gram force towards the center. Also remember the how to answer this. If we have to move 40, okay, we can't move 50 because the weight of the scale act at the center. You can't change that. It is that's the center of mass. This 40 gram force has to move. Now, when it moves here or it moves there, so this motion is correct. So this is the motion called as moving towards the center. What will be this motion called? Moving away from the center. That's why we are using this language, that move 40 gram force towards the center. Okay, and name the principle. This is principle of moments. That's what we have been using to solve these questions. Okay, so let's move to the next one. The uniform meters rule of mass 0.06 kilograms is balanced at 70 centimeter mark. So this is a uniform meter scale. So this is 0, this is 100 centimeter. The mass is 0.06. So that is acting at 50, 0.06 kilograms. And it is balanced at 70. So this is 70. And the unknown mass is hung at 94. So this is 94 and this is the unknown mass. Draw the diagram. This is the diagram and find the unknown mass. So again, we write down that statement that because the scale is balanced, the sum of clockwise moment is equal to sum of anti-clockwise moment. So we have 0.06 multiplied by this distance. So that is 20 is equal to W multiplied by this distance. That is 24. Okay, now we have kept this in kilogram. So our answer to W will also be in kilograms. So what will be W equal to 0.06 into 20 upon 24. So this will be 4 5s are 4 6s are, and 0.01 into 5. So the answer is 0.05 kilogram. Now they are asking for unknown mass. So it is 0.05 kilogram. Of course, you can convert that into grams as well. But if they had asked weight, then the answer will be 0.05 kilogram force. Okay. If mass is in kilogram, the weight will be kilogram force. Again, so once you understand the type, it becomes easier. Okay, so we are focusing on the fact that it is a uniform meter scale, so the weight will act at the center. Okay, let's go to the next question. Question 8. Again, you can pause the video, read the question, try to answer this, and then see the video ahead. So the diagram shows a balance being used to find the weight of the baby. Okay, so this is the balance that is used to find the weight of the baby, which is in the basket. Now the weight of the basket is ignored, so we don't take into account the weight of the basket. At equilibrium, the pivot is near the weight cup. Okay, so this is the pivot, and you can see that this distance d1 is shorter than this distance, that is d2. Okay, so they are asking what is the weight of the baby? Is it less than, more than, or equal to W? Okay, so if I consider the weight of the baby as B, we have three choices. Choice 1 is B is equal to W, B is less than W, and the third one, that is B is greater than W. Okay, so what is the answer? So according to the principle of moments, the weight of the baby times the perpendicular distance from where the force is acting and the point of rotation is equal to the weight times d2. Okay, so the anti-clockwise and clockwise are equal. So what we have over here, that this d2 is greater than d1. So this is d1, and therefore b has to be less than w. Okay, so since the perpendicular distance is more, the force is less. Okay, so that's the logic we have seen for few reasons. Why do you prefer a spanner with a longer arm? So if the distance is more, you will require lesser force. Also, we say that, like, if you have something like 20 into 5 will give you 100. But instead, if you do something like 50, then you will have to just multiply 2. That means if the distance is less, the corresponding weight will be more. Okay, but if the distance is more, then the corresponding weight will be less. So this is the principle of moments being used to identify that the weight of the baby is less than the weight W over here, because the baby is balancing that weight with a longer distance. A similar question has been asked, that on a seesaw, okay, you have a grown man sitting at one end. Can this man be balanced by a little boy? So answer is yes. That little boy has to sit at a further distance, okay, then he will be able to balance that seesaw. Okay, going to the next one now. Question 9. A meter scale of 50 gram force can be balanced at 40 centimeter without any weight suspended on it. So what does that mean? This is a meter scale. So 0, 100 centimeter. If you have noticed, there is a meter scale. The word uniform meter scale. So that word uniform is absent. Okay. And what is the other indicator? The weight is 50 gram, but the weight is not at 50, but it is at 40 centimeters. So another way to show it. So if you place the scale at 40, it stays horizontal. That means the weight of the scale acts at 40. Okay. So this is 50 gram weight, okay, gram force weight, which is acting at 40. Now, if this scale is cut at its center, now where is the center of the scale? Center is 50. So which part will be weighing more? Okay, so let's answer this question. So because the scale is at 40 centimeter, okay, that's the weight acting. It means this part of the scale weighs 25 gram force, and this part of the scale weighs 25 grams. Okay, so I'll draw that again to show you. This is 0, this is 100 centimeter, and the weight of the scale acts at 40. So this weighs 25 gram force, and this weighs 25 gram force. Okay, now what they are saying, if the scale is cut at 50, that is this point, okay, so now obviously this portion will weigh more. Okay, so if the ruler is cut at the center, which part? 0 to 50 centimeter will weigh more than 25. Now moving to the next part of the question, what is the minimum weight that is placed? So this is 0 and this is 100 centimeter. So minimum weight placed on the meter scale to balance it. Okay, so and it is pivoted at the center. Okay, so what is the second part saying? So this scale is now pivoted at center. So again, we know that it is going to tilt. So we have to prevent it from tilting. And for that, we need a minimum weight. So minimum weight means from the fulcrum, you have to attach it at the farthest point. So that point will be over here. Again, we write, because the scale is balanced, so the sum of clockwise and sum of anti-clockwise will be equal. So that will be 50, and this distance over here will be 10, is equal to W into 50. So that distance is 50. 50 and 50 will get cancelled. W will be 10 gram force. Okay, so what is the minimum weight to be placed? You have to place the weight of 10 gram force at 100 centimeter mark. Okay, quite an interesting question.